Hey everyone, my name is Sergey Kravchenko and I'm building my journey as an AI ML engineer. Many of you probably remember or even saw some of my previous projects, like the AI workflow automations I built on NA10. For example, the Chamber AI system that handled more than 150 real interactions in just over a month. Yeah, well, those projects were exciting, and I'm genuinely proud of them. But today, I want to tell you a different story. All right? Not about automations, not about no-code workflows, but about a personal moment that completely shifted my direction. Recently, during an interview for an AI ML engineer position, I was asked about the mathematics behind machine learning. Things like loss functions, optimizations, and generalization. And that was the moment I realized building workflows is great, but without the fundamentals, you will not get far. That's when I decided to go deeper, to start from the ground up and really study the math that makes AI possible. So today I want to show you my very first fundamental ML project. This is my kind of hello world of machine learning, a handwritten digit recognizer built entirely from scratch. No TensorFlow, no PyTorch, just Python, NumPy, and the mathematics behind neural networks. So once the training is finished, you can open this window and on the left side, you can see the canvas where I can actually draw digits. Let's try it out together. I will start with something simple. Well, I slowly draw the number 2 line by line from top to bottom. The moment I curve the top arc, like a little parabola for the head of the 2, look, the network is already locking onto it. You see, it instantly updates and starts showing a strong prediction for 2, even before I have finished the whole shape. Guys, that's when you realize it's not just reading the final picture, it's actually processing as I draw. Now, let's make it more fun. I will switch gears and suddenly draw an 8. See that? The moment those two loops connect, boom, the network jumps and predicts an 8. Pretty cool, right? Alright guys, and let's play around a bit more. Well, I will quickly sketch a 4, yeah, there it goes. Then a 9, great, 0, yeah, and even a simple 1. So you see, each time the model updates instantly, giving me both the predicted digit and the confidence levels on the right side. And below, you can watch the live stats changing the prediction, the max confidence, the uncertainty, even the loss value. This way, you can literally see the neural network thinking in real time. Now, let's quickly look at how the project is structured. As you can see, the data folder holds the raw MNIST dataset. Network.py is where the neural network itself is implemented, with forward propagation, back propagation, and training logic. Main.py ties it all together, loading the dataset, training, evaluation, and so on. And finally, the trained model file, so I don't need to retrain every time I run the app. Here is the main.py file. It handles dataset loading, normalization, and one-hot encoding of labels. It also contains the graphical interface you just saw. I mean, the canvas, the probability bars, and the live statistics. Whenever I draw something, the input is resized, normalized, and fed into the neural network for a prediction. And here is the network.py file. So this file implements a fully connected neural network from scratch. It initializes weights and bases, applies the sigmoid activation function in the forward pass, computes errors and gradients during backpropagation, and updates parameters with gradient descent. Honestly, watching the accuracy improve epoch by epoch was just a huge learning moment for me. It made the abstract math real. When training completed, the model reached around 96-97 accuracy on the test set. Not state of the art, but incredibly satisfying because I built it without any high level libraries. Just code, just math, and a deeper understanding of how learning really happens. And that's what makes this project so important for me. It may look simple, but it represents the start of a new chapter, moving from building workflows to engineering intelligence. Guys, I've uploaded the full repository to GitHub and I will leave the link in the description so you can check it out, clone it, and even play with the code yourself. By the way, I also started publishing on Kaggle. You can find my profile there, and this same project is available too, but in a notebook version. It's actually really interesting and in some ways even more convenient because Kaggle is built exactly for machine learning and AI experiments. So check it out. I will leave the link in the description as well. Friends, if you found this valuable and want to see more projects like this, leave a reaction here and drop a comment. That's not just for me. When you comment, LinkedIn understands that you're interested in AI and ML. So it will actually show you more content like this in your feed. The algorithm behind LinkedIn, by the way, are also based on machine learning. Well, not classification like in this project, but more on regression models that rank and recommend the most relevant content to match your interests. And of course, feel free to connect and subscribe. This is just the beginning of my journey into machine learning, and I'm excited to share it with you. See you!